going to dive right in here with Dr. Amelie Gaudin, who has been at UC Davis now for a year. She's assistant professor of agroecology in the Department of Plant Sciences. Got her doctorate from University of Guelph in Ontario, and she's done research with the CGIAR system in Peru and the Philippines on rice and potato systems. Her research program at Davis looks at ecological approaches to cropping systems, understanding multiple functions and drivers of resilience, resource use efficiency within agroecosystems, and applying this knowledge to the sustainable management of soils and farming systems. So, without further ado, Amelie.
All right, thanks, Mark. Good afternoon, everyone. So, thanks for the opportunity today to talk about some long-term research which has been going on at Davis inorganic system, namely at Russell Ranch. I will try to give you a snapshot of 23 years of research, and I just zoom in on the organic system, which is one of the 11 farming systems being studied at Russell Ranch. So give you a little bit of results and some thoughts as to why long-term research is important and how can it help face the next challenges. So what is Russell Ranch? Russell Ranch is mostly for a commercial farm of 1,500 acres, and it has what I call in the center kind of a jewel, which is this long-term, so I don't have a laser pointer, so I'm going to try to do something like that. Oh, that won't work. Okay. Which has a long-term trial in the middle, and then you can see the little chessboard there. Oh, you do? Great, thank you. So at Russell Ranch, we have research, we have conventional plots, we have research involving wildflower strips, some organic plots, some plots to scale up some precision agriculture research, and here is the Puta Creek with the riparian reserve that connects to campus, so experimentation can be done as well in the landscape. It is home of the Century experiment, which is composed of 72 one-acre plots, and it was started in 1993. So Russell Ranch has really been a collaborative platform since its beginning. It's part of the Agricultural Sustainability Institute at Davis, and research has involved more than 300 people as far as I counted yesterday. Researchers and students, 77 reports and fact sheets, 67 peer review publications, more than 50 industry partners have been working at Russell Ranch and specifically in the Century, at the Century experiment. So needless to say that I haven't done anything of what I'm going to be presenting today. So what is being studied in this Century experiment? Well, we have 11 farming systems, and those farming systems are being compared in terms of ecosystem services, but also in their performance in terms of sustainability, and trying to look at the linkages between the two, addressing the question of what is the long-term impact of management decision on both input use efficiency, but also various indicators of agroecosystem health. Precisely some other questions which are addressed by this body of scientists is the question of sustainable intensification. Can we actually increase sustainability as we increase food production? So those are some big overarching questions that all those researchers are looking at. How can food production system actually be designed to harness those synergies, ecological synergies, while maintaining productivity, which is what all organic production is about. And addressing those questions of resilience and ecological outcome of agriculture, given a changing climate and shift in resource availability, how do we maintain ecosystem services provided by agroecosystem? The 11 farming systems which are under study, so we have a native grass, there is a wheat-based dryland farming system, so with a comparison of wheat fallow and wheat legumes, with a winter legume cover crops, all in dryland systems. There's a wheat fallow system in irrigated as well, with or without fertilizer. There's a new system which was introduced last year, which is alfalfa tomato corn rotation, irrigated with minimal fertilizer. And then comes the systems I will mostly talk about today, which is conventional wheat tomato, corn tomato, and then a corn tomato with a legume cover crop, a transitional system, and then the organic corn tomato system, which has composted poultry manure and winter legume cover crop as main nitrogen sources. So basically a gradient of nitrogen and carbon and water input. What do we measure on a regular basis? Well, in terms of crop, the biomass, fruits, crop nutrient level, but also a lot of work has been done on soil properties, below ground biodiversity, a lot of work on greenhouse gas emission, which I will not have time to talk about today. Weeds, water use, and nutrient losses, everything that comes in is ideally being measured. And some economic returns as well. It is also used as a platform for extension and education during field days, a lot of undergrad projects as well. And what is interesting in the setup is that every plot also has some micro plots on the side, so you can actually experiment within the system without compromising the long-term data. So you have microplots where researchers have been looking at different nitrogen inputs, making variations in cover crop mixtures, even looking at gels to enhance moisture retention. So the design of the experiment is also very interesting in that it allows researchers to have some versatility as to what they want to measure. So, in summary, today I will be talking about the long-term impact of organic management on some provisioning services, regulating services, and a little bit about supporting ecosystem services. What are the results in terms of yield? Here you see the organic system is actually this blue line, and those are all the other systems. No significant difference in tomato yield between the organic and any other system from 1994 to 2015. What is interesting, though, is that organic tomato yields are actually way more stable than the conventional yields. It is, my crude calculation is 7% more stable, but we're actually looking into using some more developed statistical and non-parametric approach to look at more stable yield stability over time. If we look at corn yields, and here you have the organic is in green, you see that the conventional corn yield in blue are actually higher than the organic system, but also an integrated system which is conventional with cover crop. And that comes mostly from availability of nitrogen in the system and an impact of cover crop on moisture patterns and planting dates. What has been shown using this trial in 2007 is that they used tomato archive to compare between organic and conventional over a 10-year period, and they found significant differences in flavonoid contents, which is directly related to the nutrition, to food nutrition. And you can see here the conventional and the organic with a gradual increased concentration in flavonoid in organic over a 10-year period. And here I just show you two, and you're welcome to go dig a little bit more into the paper. But basically, in those systems, in organic system over 10 years, the food was actually more rich in flavonoids. Those compounds are also very important for pest control. In terms of pest control, the researchers have been looking at other compounds, the alpha-tomatin, which was also significantly higher in organic compared to the conventional over the course of 10 years. This is per year, and you see that this has been very variable in the conventional and much less variable, so and to a higher level in the organic system. So despite significant annual variability, the content of those glycoalkaloids was actually higher in the organic systems. Below ground, In terms of pest control, there was no significant difference over the last 20 plus years in nematodes. Most of the difference was the impact of management was actually due to shift in aggregate fractions rather than a direct effect on the nematodes. So basically, the more microaggregates you have, the more density of all trophic groups of nematodes. And again, here you have, and I will give you the list of publication at the end if you want to have more information about it. Aggregates are also very important for carbon stabilization. Here you have the relationship between cumulative sea input and soil organic carbon sequestration. It has been shown using this trial that the conversion rates are about 76%, and here you see the organic system. Aggregate stability was actually linked in a series of papers with sea input and soil organic carbon. Here, what was interesting as well and discovered in this trial, using this trial, is that there is actually a shift in the location of where the carbon is stabilized in organic system, where it will be preferentially sequestered in microaggregates, which are way more stable over time. So as a result of higher say input, carbon input, but also better aggregation, there is higher carbon sequestration in the organic system, as you can see here, compared to the conventional systems. Those samples were collected in 2005, and in 2012 some more samples were collected to do a 20-year sample at up to 3 meter depth in all the 72 plots, and the results should come out pretty soon. If we look at soil health and nutrient cycling in those different systems, we see that microbial biomass, carbon and nitrate, microbial total biomass, carbon and nitrogen, and total PLFA were actually almost 2 times higher in organic than in other systems. And here you see that actually the composition of the population was drastically different. Why does that matter? Well, if your management system is going to influence the formation and breakdown of those microenvironments, which are preferential sites for the microbial community, it's going to regulate the carbon and nitrogen input, and those microbes actually are the ones who are going to regulate both the microenvironment and the carbon and nitrogen cycle to regulate the synchrony of nitrogen supply, how much nitrogen is retained in the system or lost, and the carbon sequestration potential. Here comes a summary of about 5 to 6 papers from the Century experiments. I chose to highlight just 2. I thought it was important. It was kind of an interesting finding. The hypothesis to start with was that agricultural systems that we receive high or low organic matter input actually differ in their nitrogen transformation rates and the fate of ammonium and nitrate. And what they found was that in an organic system there is actually higher ammonification, potential mineralizable nitrogen, but also soil nitrogen supplying capacity. And when they looked at it over time, it actually shows that this greater nitrogen supply capacity goes well into the growing season when nitrogen demand by plant is still high. So you had a better synchrony of nitrogen supply in the organic system compared to a more conventional system. What was interesting, though, is that because you have this higher microbial population, which is more active, this microbial population has a greater nitrogen demand, and that led to higher immobilization of this nitrate. So you have greater recycling of nitrate within the system as well, which decreased losses. And you can see some more in these 2 papers here. So basically, from what we've seen from all the research done at the Century experiment, we have a lot of positive impact of organic agriculture on various soil, energy parameters. But what was interesting was also to look at the interaction. And when I took the data and we look at the energy, the total carbon input, and the water, you see that the organic system is here. and is actually not doing very well in terms of water use. Compared to the total carbon input and energy. So trying to address that, the last summer we switched some of the organic into drip, from furrow to drip. So we're able to produce higher yield using only 18 inches of water. And when growers came to the field, we had striking differences in weed pressure. Here you have the drip system, and here you have the furrow system. Some obvious advantages of switching to drip, but then growers, when they came for the field day, Scott told me, well, I spent decade building up my soil. It was a drip system. I'm going to effectively use a tiny little bed, and it just doesn't make sense to me to switch my organic farm to drip. And you can see some more. Caitlin, my master's student, has a poster touching a little bit on this question here. But I think it brings more the opportunity of long-term trial to really investigate complex feedback that we not necessarily think about. We're going to switch to drip. Okay, this is going to change the spatial temporal water availability. What happened to the soil biological function, the soil physiochemical properties? How does that all trigger down a change in nitrogen and carbon cycling, the externality, and the long-term sustainability to adapt and mitigate climate change? So it really gives us an opportunity to address some questions that you can't necessarily address in growers' field and bring back some answers. It also provides robust data sets. We've heard this morning the plenary speaker talk about actually these two in his address, and this has Russell Range being one of the data set as well. So it is very useful into providing robust data sets for meta-analysis. What we're aiming at is really providing continuous monitoring and instrumentation, which is very important as well because organic systems are so much more dynamic. So it's going big data, trying to get some consistent data integrated and validated using new tools. Looking at integrating the soil property with soil moisture dynamic, crop demand, and really going along the whole continuum to characterize productivity and the ecological outcome. A new project which is starting with NASA is also to look at new remote sensing and tool for diagnostic and forecast in both in organic systems as well. And something that I've been very interested in is the opportunity of this long-term approach to help us nail down what is it that confer resilience into a system. What does resilience mean? Over the last 10 years, we've been talking a lot about productivity, sustainability, but increasingly the notion of stability and ecological integrity is going to be important. And ecologists have a very complex definition of resilience, which are not very well adapted to how we explore this, how we could explore this concept in agricultural systems. So those long-term platforms allow us to look at specific stress, stability over time, characterize system dynamic, but also look into developing new statistical tools to analyze stability and then get down to the underlying mechanisms. So some things that we have also been observing in this long-term platform is how organic system can really help design new solutions to some very long-lasting problems, and this is just an example, which is the new generation IPM. Usually plant health and pest management are very centered on reducing the vector with insecticide, using host plant resistance, using breeding, eliminating the virus with molecular insect ecology. And actually our preliminary results show that the soil and the dynamic of nutrients and secondary metabolites in organic system compared to conventional system actually change the host plant attractiveness to insect pest and the virus, the vector. So just by observing some of these trends over the long term in long-term trials can really help come up with new solutions as well. With that, this is a new vision for the long-term trial in that everyone would be stuck in this infernal spiral, and we would have beautiful outcomes such as novel cropping system design and really long-term trial being a place to foster collaboration and being more of a living laboratory where we can all go and experiment within the system. With that, I invite you to come and be part of this experiment. More info on all the papers I've been talking about, and yeah, any questions?
We'll take a couple minutes just for clarifying questions.
Oh, were the same variety planted across system, and yeah, at least in terms of the tomato corn rotation, it is the same variety across system. Yeah. The reason. So, what's the reason behind an organic grower being reluctant to switching to drip? His reason was that he's been building soil health for so long that he wanted to use his old soil, and so by just wetting a very small part of your soil, he was just relying on organic nutrients as well. So what happens to organic nutrients in drip irrigation? Your compost, your manure, it just changed the whole synchrony and delivery of nutrient to your crop. So it was just a big switch, and to him it didn't make sense to just build up your soil and then just use a very tiny portion which is wet. And he was actually very concerned about, can I still build my soil health with a drip system? All right, thank you.
Thank you, Emily. Very good.